Welcome. Today I want to look at iterables. So I want to add support for iterating over things to my language Plum. So let's create a new file in the standard library called iterator, I guess. And iterators are actually an interesting data structure because they are not, you don't really inspect the internals of them. Unlike other data structures like lists or maybe or bool or result or string or something, you don't look inside iterators. Instead, iterators define themselves by what you can do with them. They define themselves by their behavior. And that's an indicator that iterators, you don't want to define the implementation, but you rather want to define the interface and just have a function in there. So let's actually do that. Let's define an iterator as just a function, which in Plum works with this backslash. A function that takes nothing and it returns something. Now, what does it return? Well, if we have an iterator over ints, for example, that should return ints, I guess. So iterator is parametric over the parameter. And this lambda then returns an int. This is not sufficient though, because now we would just have a lambda that returns one integer and that's it. What we really want is to return a sequence. So return maybe a struct that contains an item of the type t. Let's maybe put parentheses around that. And then the rest, which will be a function that you can call to get the rest, and that will again be an iterator. So an iterator is actually a recursive type. And because these iterators, they should be able to end at some point. Yeah, the function shouldn't always return that, but only sometimes. So let's actually wrap that in an enum that has variants for, either this is empty or it is more with this. This is pretty dense. Okay, let's review that. An iterator of some type t is just a function that takes no arguments and it returns this enum. It either returns, well, this iterator is actually empty, there is nothing inside. Or it returns, well, there is more stuff inside, this right here. And then you get the item and the rest, which will be another iterator that you can then call again to get more, to get the next item. Yeah. So in the last video, I added this built-in call function because in Plum, syntactically you can only call functions with arguments. So now there's this built-in call function that takes a lambda that takes no arguments, and it just calls that lambda and gives you the return value of that. And you would have to use that for iterators. Although for iterators there's a function with a better name, a better semantic fit, and that is next. So given an iterator of some type t, you should be able to call next on that. And that should give you this. Yeah. And the way that is implemented is by just calling the built-in call function on the iterator. Reasonable. That seems reasonable. All right. Yeah. I'm not sure what else to do. Let's maybe try to use that, and well, yeah, we need to export that and so on. But how can we? What's the minimal example of using iterators? Oh, I guess in the list module, which defines a linked list, we can support iteration for that list. I think that would make sense. And maybe remove the map and get functions in favor of map and get functions on iterators. So let's maybe just add an iterate function that takes a list of t and it returns an iterator. Okay, so this function, this iterate function, is supposed to return another function that takes no arguments, and that you can call to get either empty or more, depending on whether the list is empty or more. So we need to switch on the list, I think. And if the list is empty, then the iterator will return empty as well. If the list is more, then that contains, that contains an item and the rest, which will be another list. The iterator is pretty similar to a list actually, except that we have an additional function call indirection here, which also supports endless iterators and stuff like that. Well, I mean, iterators are basically lazy lists, I guess. You can look at it like that. So, okay, we have more with an item and rest. Yeah, so in the case of more, we actually want to return more from the iterator with an item, which will be the list item, and the rest, which will be, the rest of the list, but that is a list, not an iterator. So we need to iterate on that to get an iterator. That is crazy. Okay, so let's see. We have, this is just a function, and we call that, yeah, an empty list maps to an empty iterator result thingy. And if there's more on the list, then we kind of wrap the rest in a lambda to make that into an iterator. Yeah, and the other direction would be converting an iterator to a list. And then I think we have something that we can test. Then I can just create a list. I can call iterate to get an iterator, and then I can do, I don't know, collect or toList or whatever to turn that back into a list. And look at that, check if that works. Okay, so given an iterator, we want to be able to convert that into a list. How do we do that? We call iterator.next, and that returns us either empty, in which case we'll just return an empty list, or it will return us more, in which case we will also return a more node with an item being the more item and the rest being more.rest, which will be another iterator. And we can call toList on that. Yeah. I think that's pretty elegant. Also, I think we can move that on the same line, perhaps. Yeah. Okay. Nice. This is coding-wise, this is pretty minimal, So now let's try that out. Let's say, yeah, there will be errors when compiling this. I'm pretty sure, because iterator is not known here, it's not imported. Next doesn't exist, stuff like that. Maybe I should compile the compiler into a soil file so we don't have to wait that long to compile the compiler itself. Yeah, let's do that. Let's do compile the compiler. That takes some time. Damn, yeah, Martinez is not the fastest language, because it doesn't do any optimizations at all. Yeah, but now there's the Plum compiler, yeah, which works nearly instantly. Okay, so 54 in list. Here, 54 and here. Yeah, okay. Yeah, iterator doesn't exist. So let's import that. Let's do, let's sort these alphabetically. So iterator, and from iterator, hang on, let's maybe first export stuff in here. So we want to export iterator of t and next of an iterator of t. Yeah. So that in here we can import iterator of t and next of iterator of t. And also in the main call module we want to be able to export that. Like that. Okay, yeah, inside the iterator module, call isn't known. That makes sense. Oops, don't know what I did there. So we want to import that. Import call of a lambda that returns nothing. Yeah. Okay, that worked. Nice. Hang on, that means that we now have this output.ground file. And we can then run that to get 42. Okay, hang on. What does the playground do? The playground is defined in here. Okay, let's maybe create a list of 1, 2, and 3 and iterate over that and then convert that back into a list and then get the item at index 0. Yeah, we need to import the list function, so list of ttt. Oh yeah, and iterate on a list of t. Maybe not. Oh, I see. I think we need to export that from the standard library. Yeah. And then here we also need to import that to list on an iterator of t, just like that. Okay, try to use a workspace test playground iterator, but that type doesn't exist. Yeah. And finally get on a list of t and it. Unreachable. Well, that's not great. I have an idea where that comes from. Let's just take the length. Yeah. Okay. And maybe run that. Yeah, the length is 3. Okay, hang on, that worked. First try. Well, apart from the imports. Okay, so we allocate the list 3 nodes. We allocate something else, and then we free those. then we, I think this is actually iterating over that. So we free the original nodes. Maybe. Then at some point we allocate the new nodes. Sure. Okay, that is pretty promising, I guess. So what makes iterators cool is that we can do stuff with them, like transformations, in a quite general way. So let's actually remove these map and sum, and instead let's define them on iterators. Yeah, I think sum is going to be the most interesting one. Sum on a list. Nope. Sum on an iterator of ints will result in an int. Yeah. Oh, so sum is already quite high level, I guess. Let's build map first and then look at sum. I'm also like write down some ideas. Map and filter are, I think, the most common ones. Yeah. Actually don't know. Oh, like skip some fixed amount of items and take only a limited amount of items. Cycle, if you have like a list or something and you want to cycle through that again and again and again. Oh, maybe not. We can also add more of these iterator functions as we need them. To get the first one, the last item, the end item. Yeah, the sum. I think that should be. I could also look at the Rust standard library, or like Martinez standard library, and zip is quite common. And some sort of enumerate. Yeah. I'll just write all of these down and we'll see how that goes. Alright, so mapping an iterator of A, sure, with a mapper that turns A into B's, results in an iterator of B's. Sure. Now this actually is just a function, as any iterator. A function that if you call that, then it calls the next on the original iterator. And if that returns empty, then we are also empty. If that returns more, then we also return more with the item and the rest. Yeah, I think that's fine. Let's see, compiles, amazing. Yeah, I'll also test this later on. Okay, so then filter an iterator using some predicate that takes an item and returns whether that item should remain in the iterator. Okay, I guess let's copy this as the first draft and then change that. So if the original iterator is empty, then we are also empty. Sure. Otherwise, we are not always more, but instead, as we'll check node.item, we check the predicate, and if the predicate returns true, that item should remain part of the iterator. then we'll do that. Then we'll return more with that item, and the rest will be the rest of the iterator filtered by the predicate. Yeah. If that is false, if the item should not be part of the result iterator, and then we'll just get the rest. We'll filter that using the predicate, and then we'll call next on that. Yeah, and this next call will basically call ourselves recursively, and we will continue calling ourselves recursively until at some point the iterator is empty or the predicate says true, and that is what we'll return. So we return the first, the next item that matches the predicate. Cool. Let's see. Bool doesn't exist. Right. So we need to import some stuff. Oh yeah, I guess like that. Try to call lambda with wrong types. Okay, this is interesting. Let's see. Oh, node. Node is a weird name for that, because for lists that made sense. Here I think I'm going to call that more, maybe. The more payload, the structure. Oh, I see. It calls predicate of more and then calls item on that. But what we want is this. Yeah, okay. Pretty cool that these kind of type errors get detected. Okay. Yeah, we have filter. That's cool. Then skip. Also for this, some sort of fold or reduce would be nice. The list is getting longer and longer here. Okay, so skip. Skip takes an iterator and an amount to skip, which will be int, and it returns another iterator. All right, and this is just a lambda, and when you call that, it actually calls next on the iterator. And if the iterator is empty, then it also returns empty. If the iterator is more, then it checks whether the amount is 0. If it is 0, then we like that. We just return here's more stuff with the item and the original inner stuff, the rest of the iterator. Otherwise, we call ourselves recursively. We kind of ignore the item, yeah, and we call ourselves recursively on the rest with amount -1, like that. And that just returns an iterator. We want to call next on that to actually get the item, or empty if the inner iterator ends first. That's pretty cool. But that doesn't compile because we don't have ints. do want ints. And also like minus on int, and equal on int. Need that as well. Iterator. Okay. Then taking from an iterator. That should basically limit the iterator. Yeah, let's again copy that and fix that. So if the iterator is empty, we return empty as well. Wonderful. If the iterator returns more, well, if the amount is 0, hang on, if it is 0, then we just return something. And we shouldn't return anything, so then we'll just return empty. Oh yeah, that makes sense. Yeah. If the amount is something else, we should maybe add asserts that the amount is positive. Might be useful. Yeah, I don't know. Okay, so we do, yeah, let's do that. Let's add assert amount larger or equal to 0 here as well. Yeah. If the amount is not 0, aka it is larger than 0, then we will return more. With an item that's just going to be the original item, so more.item, and the rest is going to be more.rest dot take of amount -1, but not dot next, because we want that to remain lazy. Let's see. So I guess let's say we do take of 2 on an iterator. Well, we just have this assert and then we return this lambda. And then when you call that lambda, we call the inner iterator. If that is empty, we return empty as well. Otherwise, we check is the amount 0. No, it's 2. So we return more with that original item. And the rest of take 1, which will be another iterator that only returns one item, because that will then return more with rest being the original rest take 0, and that will then return empty. Okay. Okay. Okay, so larger equal is definitely a function that we need. Assert as well. I'm actually not sure if we have that at all. In never, maybe? No, we have crash. Let's add some sort of assert, I guess, in a test file. Yeah. Some sort of assert that takes a condition, which will be a bool. That returns nothing. And basically, we switch on the condition. If the condition is true, then we just return nothing. Otherwise, and nothing being an empty struct. Otherwise we crash. Yeah. Let's also have an assert with a message. Well, yeah, something like that. So we need never, hang on, we need crash with a string. We need strings and also plus for strings. We need nothing for the nothing type. We need bools for the bool type. Yeah. And let's maybe export that in here. So and then in the iterator we need that as well. How do we call that? Assert with a bool. Nice. Then zipping iterators. Zipping iterator. I'll move first, I guess. And second. And that just returns an iterator of something. I'm actually not sure. Could call it A and B. And maybe the types AA and BB. And then that has an A of the type AA and a B of the type B. Something like that. Yeah, I guess. That's cool. All right. So we zip to iterators. They should have the same length, I believe. So what we do is we do iterator.next. Hang on, we do a.next. And if that is empty, then b should also be empty. So we do b.next, switch on that. If that is empty, then everything is fine and we just return empty. If that is more though, then we crash. Zip iterator should have the same length. Yeah. Yeah. This needs to be more indented. Yeah. If that is not empty though, and there is more in here, we switch on B again. If that is empty, well, that is a crash. If that is more, we now do something. We want to return more, definitely, of well, with an item that has an A, which will be more A dot item, and a B, which will be more B dot item. And then we have the rest, which will be the zip of more A dot rest and more B dot rest. That is pretty cool. All right, then enumerating things. We have an iterator over some A, and we want to enumerate that. That means we return an iterator with an index, maybe. I think index is a fine name, and an item, which will be the A. Yeah, this will be a lambda, and it will call the first it will call the iterator. Yeah, copying that from up here is not the right approach here. If the iterator is empty, then we just return empty. Oh, I see. We need to keep some extra state, I guess. Keep the count. Start count, start index being an int. Yeah, something like this. I'm actually not sure if multiline is supported here. Meh. Yeah, let's move that. Let's replace this with enumerate. Iterator.enumerate with the start index 0. So call that function down here via overloading. Yeah, and then in here, if there is more, we can just do more. An index, which will be the start index, and the rest, which will be the more rest dot enumerate with the start index +1. I think that should work. Cool. Yeah. All right. So then the first item of an iterator. Seems pretty easy. Let's say that returns a maybe. So this calls next on the iterator, and if it's empty, then we just return none. If it is more, then we return some with that item. Last on an iterator, oh, that's actually need to maintain some extra state, I think. So that's going to be similar to this one. Not as complicated, but last on an iterator with maybe like the previous item. we call next. If it's empty, then we just return the previous one. If it is more, then... Oh, hang on. In here we can directly check if iterator next. If that is empty, then we just return none. If that is more, then we actually call more.rest.last, with the previous being more.item. Yeah, and because we know that this definitely returns something, this doesn't even need to return maybe, so we can do that. Yeah. All right. So first, last. Then the getting the nth item from an iterator. Ooh, that I guess is maybe a, and that is just iterator dot skip. Oh yeah, this needs an n. We skip that many items and then we just get the first. Nice. I think I want some sort of unwrap all with a default value. That's weird. Yeah. Yeah, let me first try to compile that. See if there are iterator. Well, that's a bit extreme. Yeah, maybe doesn't exist. True. Crash doesn't exist. That would be never. And that means we need strings. True. Yeah, there is no matching function named zip for the arguments. Boom. Oh, I see. Because again, this just does zip of more a. Okay, yeah, we need plus. I can live with that. All right, let's try to call these. So we have a list of 1, 2, 3. and we iterate on that. And now let's say that's well, we can't really do anything useful with that, I guess. Okay, let's implement fold and reduce and sum, and then apply this stuff. So folding, what is folding? Folding is take an iterator, taking a state, an initial state, and a folder that takes the state and an item, and it returns you a new state, and in the end it returns a state. S being the state type. And that consumes an iterator. So this actually calls iterator next. If that is empty, it's just the initial state. If that is more, then that calls the folder using the initial state, and the item, and that then returns us a new state that we will pass into that will give into the next iterator, if that makes sense. So we do more.rest.fold with that being the initial state. Yeah. And reduce, I believe, is basically that, but without an initial state. And the reducer just takes two items and produces another item of the same type. Yeah, the way that works is we can just say, I think that actually returns a maybe. Because if the iterator is empty, then this just returns none. But if that is more, then this is really just like a fold. Where the initial state is the item. Reduce is something like get the sum of a list of numbers, and the reducer would just add two numbers, and here we would get the first number, and we call plus, we call fold with the first number, and this calls the plus function. The folder would be the plus function with the first number and the current number, and do that for all numbers. Yep. So taking the sum of an iterator would actually fold over the iterator. So iterator dot fold with the initial state being 0, and the folder being a lambda that accepts A and B and returns A plus B. Just adds them together. Oh yeah. All right, 104 down here. What's going on there? We have fold function. Okay, yeah, for the args. More.rest is iterate of a's. Oh yeah. Yeah, this needs 3 arguments. The iterator, the initial state, and the folder. The iterator, the initial state, and the folder. Yeah, here we have none and a as return types. Yeah, this needs to be some thing. All right, let's see. So we iterate over this list, and let's say we put that on multiple lines, and we actually iterate over that and take the sum. Meh. Oh, I see. But this is only because we need because sum works on an iterator of ints. Maybe not. All right, the standard library doesn't export them. So iterator, oh yeah, this doesn't work for one. We should type check these, come to think of it, like, it's important. Okay, let's see, we have iterator, and that contains iterator and next, yeah, but also map. Mapper that turns A into B's. It has filter. Taking an iterator and a predicate. That tells us whether something should remain in the iterator. It has skip. That takes an iterator and an int. We have take, very similar. Takes an iterator and an int. We have zip, which takes iterator A. Well, let's call it AA, yeah, and an iterator B. No, yeah. I'll keep it consistent. We have enumerate that takes an iterator, and that's it. Like this other enumerate, this one is not exported. This is only internal for this module. We have first on an iterator, we have last on an iterator, we have n on an iterator, we have fold on an iterator, oops, and a state and a function that maps the state and an item to a new state. We have reduce, takes an iterator and a reducer. And finally we have sum. That can sum an iterator of ints. Okay, so we can sum these up to get 6. That is pretty cool. that is super cool. Let's do, I don't know, something, say 120 and 40. Yeah. Ah, now I need to know hexadecimal. Well, no, that's on me. Okay, what I can do is map these. So say let's map each item to something, to the item plus 1. Sum those up. Oh no. Yeah, we need to import the map function. Huh. 9, because the sum of 2, 3, and 4 is 9. Yes, that is pretty cool. And now we can filter that. Oh, cool. And be like, yeah, we only want items that, I don't know, are larger or equal than 3. So we don't want the 2. And yeah, larger equal 3 ints, need to import that. Oh yeah, and filter as well. Oh no. Yeah, okay, so in the ground VM, let's allow some bigger files, I guess. 10,000 bytes is the bytecode already. That's quite a lot, actually. Well, yeah, let's compile that. I know that Zig's version. This is built for Zig 13, I believe. Build on Zig.zone. Why are there so many backwards incompatible changes in Zig? That is a bit annoying. Yeah, there's like an add syntax or something. Let's just do that, I guess. Sure, let's add a fingerprint. Zig is weird sometimes. Type U8 is not indexable and not a range. That is actually true. Hang on, where is that? Yeah. What the hell? Doesn't make any sense. Why is stuff not working anymore? I didn't change anything, sadly. Yeah, I did this now. Okay, apparently I did some debug printing without committing that. I mean, sure. But that shouldn't... And that should still work. I don't know. Okay. So we have call stack.pop. Oh yeah, in this case we know that because we trust the bytecode. We know that we called something before returning here. So there is something on the call stack. Similarly in 243 pop byte, yeah, we know that we believe there's a byte. Okay. Okay, nice. Now let's walk through that. Think through that at least. So we have 1, 2, 3, we iterate over that, we map the individual numbers. 2, 3, and 4, we filter those for numbers that are larger or equal to 3, so the 2 gets removed, we only have 3 and 4, and we take the sum of those, that's 7. Phew, okay, that works. that is amazing. What is really cool is I did nothing in the language itself in this video. Like, this is entirely in the standard library, and this is powerful. Like, iterators as a concept, that's nice, very nice. Let's commit that, I guess, and this as well. So what else do we have? Like, yeah, let's discard these. It is in there commented out, that is totally fine. Yeah, this is apparently the music version requiring some other stuff. I mean, that is, sure, let's keep that in there. Yeah, I guess the formatter is a bit different maybe. This though, nope, not gonna commit that. Oh yeah, I do want to commit that because the main function accepts yeah, the main function accepts an integer, so that makes sense. Yeah, or as like a separate fix, I guess. So update to 0.14 and pass provide an int to the main fun. Okay, and then at plum, what I want is add iterators. Clean. Yeah, let's also look at what Rust does. So I think in the Rust standard library, Rust iterator in the standard library. Beautiful. So they have a next function, and these are the provided methods, which is, oh, that is quite a bit. Let's see if it makes sense to add some of these. Advance by. No, that doesn't make any sense because this is similar to skip. In our case though, iterators are immutable, like all the other values in the language. So I think we don't need that. All actually makes sense. Let's add all. Sure. So all would do something. So we have an iterator of something, and we take some predicate that tells us, is that true? and this entire thing results in a bool. I think we can just map that with the predicate to get a list and an iterator of booleans basically. And then yeah, let's do that as a separate thing, maybe all true on an iterator of bools that returns you a boolean, and this just maps them and then calls all true, which is defined down here, or up here, sure. And that just reverses on the iterator. So iterator next, if it is empty, then yeah, we consider that to be like all empty, like all 0 bools are true. Yeah, if there's more, well, we switch on the more item actually. If that is true, then we need to call ourselves recursively. So then we do more.rest.allTrue. Otherwise, we can immediately like early abort with false. Makes sense. Okay, so all makes sense. Yeah, then any, that's like the opposite. Any sure. Is any of these true? This uppercase thing would remain the same, but in here we do if the item is true, then we just immediately early abort with true. Otherwise, we call iterator dot more.rest dot any true. Yeah, and then we have the more general any on an iterator that takes a predicate and that just does iterator dot map predicate dot any true. Nice. Okay, so then find. Interesting. And find map. Okay. That there was. Hang on, how are they ordered? They are not really ordered in any way. Well, yeah, let's go through that from top to bottom, I guess. And this is not the order in which they are here, which is weird. Okay, so we have a next chunk. No, let's not do that. Size hint. No, count. Count, sure. Why not? Count number of items in an iterator. That's just going to be an int. And it's going to be iterator dot next. Oh, and there's going to be recursive with an already like that. And that calls iterator. Hang on. We already have fold, I believe. Like, yeah, fold. Let's use fold. Sure. Yeah, that simplifies stuff, because then we just have to fold the iterator. Start with 0, and then we have this count, which is an int, and the item, which is a t, which we ignore, because we just return count plus 1. That is nice. Okay, we have count, we have last, already have that. Advanced by, no, don't need that. And we have that step by. Oh, that is interesting. Step by. Sure. Sure. Yeah, where do I put that? I guess. Yeah, just here. That's fine. Step by on an iterator. First element of the iterator will always be returned, regardless of the step given. That makes sense. Yeah. So let's do. I mean, this is that. Trust is always given. Step by, but skip first. I don't know. Basically, looking at what's what's the next item of the iterator. And step by, but skip first. Yeah, no, we would skip some amounts, step amounts of items. We'll look at the next one, if that is empty. Then we also just return empty. If that is more, then we just return more with an item and something. The item and the rest being more.rest.step. By skip first of that step. Yeah. Okay. And in here we do something. We do iterator next. If that is empty, then we just return empty. If that is more, then we just return more of some item, and the rest being more.rest.step when I skip first of that step. Cool. Ooh, chain. Like that. Oh, I like that. Chain is cool. Yeah. And that returns, oh, hang on, iterator of the same element, same t, let's say. Yeah, the way that works is, I don't actually know. We return an iterator, and when you call that, we iterate through the first iterator. So a.next. And when that is empty, we then just return b.next. If that is more, then we return the item and the rest being the more rest chain with b. Yeah, that's cool. Cool. Okay, chaining iterators. Then zipping, we have that. Intersperse. It's a new iterator which places a copy of separator between adjacent. I see. That actually makes sense for like joining texts or something. Yeah, like here. Yeah, let's do that. Intersperse. Crazy name. Separator. If the iterator is empty, then we just do, I don't know, we just return empty. Yeah. If the iterator is more, actually, how is that implemented? Oh, thank you. Import super intersperse. Oh. Can I jump there? No, can I? we also need to know whether there's a next item. But yeah, this is quite, like the state you have to maintain here is quite complicated. All right, so yeah, if there was more, intersperse with the separator next. And that's actually fine, yeah. But then we'll have a third one, intersperse with the item next. Any item except the first one. And then we also have a next item, I guess. Let's walk through that. So if this is empty, we just do empty. If it's more, then we do well, we don't want to call next on the other iterator yet. So we just do more, where we have the item, and the rest is going to be the rest with the separator next. And in here we will actually let's call this like after item, maybe. Yeah, I think that is nice. And this is after separator. So after we've printed an item, if we are then asked what's the next thing in the iterator, it depends. If there is another item afterwards, then we want to print the we want to emit the separator and then that item. If there was nothing coming afterwards, then we just want to say, well, we are done. So we have to switch on the next one. If that is empty, then that's just that. If that is more, then the item will just be the separator, and the rest is going to be more dot rest dot intersperse after separator with the separator and the next item, which will be more dot item. Yeah. And after the separator, we will then, we don't need to call iterator.next because we've already done that here, but yielded the separator. So here we can just immediately say we have more, the item being the next item here. And then the rest is going to be the iterator. Yeah, like that. And that is pretty cool. I have this tiny state machine that works, switches between these three functions. We start in this one, then we like intersperse after item, which goes here, which when asked for the next item, it actually just checks whether there's a next item, and if there is, then we instead yield the separator and store the item as this next thing. That is pretty cool. Yeah, all right. So we have intersperse with, don't need that, because we don't have like mutable closures. No. Map, hell yeah. For each, nope, that only makes sense for mutable. Yeah, all side effectful closures. Filter, hell yeah. Filter map, both filters and maps. And the function returns an option. That is actually nice because I think it may simplify code here. Let's merge these two. How's that? F. It's called F. Beautiful. I was wondering what's a good name for the function? Really? Oh, I've got mapper. Yeah. Yeah. So if that is some item, yeah, then we'll just do that with a mapped item. Cool. And then map becomes simpler because that's actually just iterator.filter map. Where the function that takes an item and it just always produces some other item. Calling the mapper. Like that. That's cool. And filter also becomes easier because that's just, you know, filter map. I think I wanted to put spaces in there, I believe. Filter map. Like given an item, we just we just call the predicate on that item. If that returns true, then we just return the item and map to that same item. Otherwise, we want to omit that. Yeah. Nice. Oh yeah. There is a lot of stuff here. Oh yeah, this needs to go here, I think. we have filter map. We have enumerate. Hell yeah. Peekable. Yeah, all iterators are peekable. Like, we don't have mutability and stuff like that, so this is quite yeah, we don't need to care about that. Skip while. Yeah, okay. Skip while is interesting. Be similar to this, except we don't determine whether we're done on the amount. The amount doesn't determine that, but rather the predicate. Oh, it needs to be the other way around, I think. Yeah. If the predicate says, well, I don't want to skip that, we're done, then we just return more. We return that same item, makes sense. If it says, well, I want to skip that, we actually just do skip while with the same predicate. Call next on that again. Yeah, same with take, I believe. Take while and takes an iterator and a predicate. Yeah, and these also have to be flipped. So if it says, well, nope, I don't want that anymore, then we'll just say, well, we're done. Otherwise, we take that item. Call ourselves recursively. Yeah, this returns an iterator A. Yeah. Okay, so we have skip while, we have take while, map while, map while. Okay. Oh yeah, we can do that with take while and map. Yeah, okay. Let's guess it's called, oh, predicate. Oh, nice. Interesting. Yeah, that's similar to iterator dot map using the predicate dot filter dot take while item map that where every item is mapped to item.unwrap. Cool. Yeah, skip with an amount and take scan. Yeah, no, that's flat map. That is, I know that. Oh, so if the closure itself returns another iterator. I see. Yeah, we can do that. So given an iterator, and a mapper that maps an A to an iterator of B's, we want to return an iterator of B. For each item we just call the mapper, and we kind of, yeah, put all of those next to each other. So that would be, we take the iterator as to the explicit form, I guess. Iterator next, and then if that is empty, then we are also empty. If there was more stuff inside, then we map the item. Giving us another iterator. And then we want to chain that. We can also do like model item mapper, I guess. Yeah, and chain that to the rest of the iterator. So more.rest flat mapped using that same mapper. Okay, so this depends on chain, so I think I'm going to move that further down. So these are like roughly sorted by what depends on what, which makes this a bit easier to mangle, I think. Oh yeah, is some, do we even have that? I don't think so. No, but I think it might make sense. Oh yeah, this is an empty. That is an iterator. We chain that. Oh yeah, and then we want to get the next element. That is crazy. Okay, yeah, that is flat map. Then flatten on an iterator of iterators, probably. Sure. So we have an iterator, which is an iterator of an iterator of A's. I mean, we could just say, let's, you know, flat map that with the identity function. So given an iterator of A, where this just returns that same iterator. And flat map will make sure of and chaining that inner iterator with the rest also mapped. Yeah. Map windows. Let's not do that yet. Fuse creates an iterator which ends after the first none. Doesn't make sense for us because once the thing returns none, like it doesn't even return the rest that you can use. In Rust, that's a bit different with like mutable stuff everywhere. Inspect, same thing. Like this is, yeah, this is useful for like logging or side effectful things like printing. Yeah, no. By ref, nope. Collect, nope. We have specific functions for like toList or to something. Troublefish is ugly. And try collect. Yeah, no. For now, let's not do that, I guess. No. Collect into. Nope. Partition. Oh, that is actually cool. Yeah, that is pretty cool. Yeah, let's maybe do. I'm gonna add a to-do for that, I think. Yeah. Okay. Yeah, try stuff. Sure. Yeah, did that. Yeah, we have that. We have that. Yeah, try stuff. We have all and any find. Sure. I mean, find is just I guess find just is like filter using the predicate and then getting the first one. Simple. Find map. Let's not do that. Let's add some of these on demand when I really need them. Yeah, I can imagine position being our position. Come on. Yeah, max, min and max. I like those. Yeah, no. Unzip. Interesting. Cycle. Yeah, min and max. Let's do that. So that actually only returns a maybe end because the iterator may be empty. So that is iterator dot. Oh, hang on. Maybe we could just do iterator next. And if it's empty, then we'll just return none. If it's more, then just do more.rest dot reduce oh yeah, I think we just want to use reduce directly. Iterator.reduce, and that returns a maybe, and it's called with two items, a and a being an int and b being an int, and it just returns the minimum of a and b. Same with maximum. Nice. Yeah, then cycle. Yeah, that is just she don't know. I think we want to chain. Cycled iterator at the end of that. That is pretty amazing. Crazy. Crazy array chunks. product, I guess. How often do you really need that though? Yeah, okay. Meh. If this compiles, I'm happy. I'm sure there were some bugs in there. Apart from those that got reported, like integer stuff. Hang on, let's min and max is probably not defined. Oh well, yeah, these, but I think exports are not checked right now. So you can just import stuff even if that's not exported from the module. I gotta fix that. But yeah, we have min for int and max. That's the important part. Fair enough. Yeah, I should really like export the iterator stuff, or maybe split the editor here. So I can at least look at that side by side. Yeah, sorry for the video. This is probably unreadably small now. Okay, filter map takes an iterator A and a mapper that maps A to maybe B. Sure. Yeah. And we have map. We have filter. Yeah. We have skip. And take. And skip while. And take while. And map while. Amazing. And then we have first and last and nth and step by and chain and flat map. And then intersperse. That is crazy. Like this, there's a lot of functions. And flatten. Fold. Reduce. Count. Sum. Min. Max. Cycle. Find. All true. All. Any true. And any. Yo. That is by far the biggest module here. Crazy. Yep. Okay. Yeah, I guess. Let's make sure that works. Yeah, it does work. Cool. And let's commit that. And maybe add Rust iterator functions. Nice. Yeah, we can now use iterators, which is pretty cool. All the map and filter and sum and flat map and whatever you want, it's all there. Yeah, I guess that's it for this video. See you in the next one.